Hello, students, and welcome back. We're going to begin our semester looking at polynomials. And the first operation that we're going to perform on polynomials is going to be adding and subtracting. And so to do that, we have to recognize like terms with our polynomials. So I've got a little diagram that I thought we would look at just as an introduction, where we identify the like terms. So I'll just do this by doing some shading in yellow of the like terms. So I'm going to start here in this top left corner with 5g to the second. Now, as I look through, I want to see, are there any other terms that have a g with a 2 as an exponent? So as I look along the first row, I don't see anything. As I look along the second row, again, no like term. I come to the third row, and I have 7g to the second. That is, I think I'm just going to circle it. 7g to the second, that is a like term with 5g to the second. Continuing on in that third row, I see 4g to the second. That is also a like term. In my last row, I see 0g to the second, and I believe that is it. And then we can go on. I'll change colors, and we'll look for any terms that just have an x. So this negative 1x would be a like term with anything else that would just have an x. So I don't see anything in the top row. In that second row, I see the 2x as a like term. Another like term is the negative x in the third row. That negative is the same as negative 1x. I see a negative 6x also in that row. And then going on to my bottom row, I see 1/4 x. So again, I'm looking for the same variable and the same exponent for terms to be considered like terms. So switching colors, now I'm going to look for like terms with my x to the second. So 5x to the second would be a like term with, in that same row, negative 1x to the second. In that same row, 0.6x to the second. And as I continue on looking, anything that would have just x to the second. So in the bottom row, negative 9x to the second, and just x to the second. That would be like 1x to the second. Those would be like terms. We can continue on looking at the negative cx. I would have to find like terms that have the c and the x. So as I continue to look, I see on the bottom row 8cx. So those would be like terms. Nothing else has just a c and an x. I'll switch colors again. I'm looking at 7y to the second. So anything that would have a y to the second in it, and only y to the second. It can have a number that differs, but the variable has to be the same. So I've been circling in the top row. I've got 7y to the second and 4y to the second. In the second row, 8y to the second. In the third row, 10y to the second. and in the bottom row, negative 3 y to the second. Now, another like term could just be a number or a constant. And so we'll look at 11 and see if we have any that are just numbers or constants. One that you might overlook is the decimal, 47.56, but that is a constant. 19 is a constant. 1 is a constant. 1/2 is a constant. Anything that just has a number and no variable would be considered a constant. All right, so now I'm going to look for something that has F, C, and X in it. Has to have all three variables, F, C, and X. I do not see anything that's a like term with that. I'm going to look for H, anything that would just have H. And I do not see like terms with just H. I'm going to look next at the C squared, the negative C squared. We do have like terms there. And I've run out of colors, so I'm going to go back, but I'm going to change my design. So I'm going to use a rectangle now. So I'm going to put a rectangle around negative C squared and positive 5C squared. And in my next row, 2C squared. And my bottom row, another 2C squared and an 8C squared. And so those are all like terms. And then my next one is with a y to the second and an x. And I have to be careful as I'm looking at that. So 0, y to the second, and x. It's tempting to choose this one, but this 5x to the second y, but the second power is on the x and it has to be on the y. So I'm looking at 4y to the second x. That would be a like term. And that would be it. As I move on, I want to look at the 5x to the second y. I'll put a rectangle around it because we do have some like terms. In the bottom row, we have 10x to the second y and negative x to the second y. So those are like terms. As we look at 6g, I can put a rectangle around it, as well as 3g and negative 9g, put a rectangle around it, and 45g. All of those are like terms. And so I've got the whole second row accounted for. My third row, I'm looking at GH, and I see that I have a like term with 4GH right below that. So my only terms that are left unmarked would be FCX. It was the only term that had all three of those variables, and 5H, and it was the only one that had just the H. So like terms are terms that have the same variable and the same exponent on those variables. And so we're getting ready to work with what we call polynomials. So poly means many. And so a polynomial is a monomial. Monomial means one term, or the sum of monomials. So where you have individual terms added, and we could also use subtraction, since sum is the same as adding a negative. And this sum of monomials, each term would be a monomial. The Two types of polynomials that have special names would be something with two terms would be called a binomial, and something with three terms would be called a trinomial. And beyond that, we just refer to polynomials. All right, so when we add polynomials, we will identify the like terms, much like we did in the chart that started our lesson, and we will combine the numbers and keep the variables and keep the exponents. So I will clear this screen and scroll on up so that we can go through those examples. So in the examples, you have parentheses. We're going to rewrite without the parentheses. So we're going to distribute a 1 to this second parentheses and therefore remove it. You can kind of think of distributing a 1 to both of them, and that removes the parentheses. So we'll have 7y to the second plus 2y minus 3 plus, and then if we distribute a 1 to remove the parentheses, we would have 2 minus 4y plus 5y to the second. And so then we will combine like terms. We will look for where we have the same variable and same exponent. So I have a 7y to the second and a 5y to the second. I'll add the 7 and 5 and then keep my y to the second. So 12y to the second. Then I'll look for a like term with the y. So I have a positive 2y and a negative 4y. I'll combine those to negative 2y. And then finally, I have a negative 3 and a positive 2. I will combine those, and negative 3 plus 2 is negative 1. I like for my answers to be in descending order of degree, and that is determined by the exponent. So I want my highest exponent first, and then just going down from there with my constants last. So 12y to the second minus 2y minus 1 would be the simplified polynomial. For my second example, we'll follow the same rules. I am going to show you an alternative way to rewrite after you remove the parentheses. So thinking of distributing a 1, I could remove my parentheses, 4x to the second minus 2x plus 7, and then distributing a 1 again. Now, as I do this, another way that you can organize is to line up the like terms vertically. So 1 times 3x would be a positive 3x, and I could line that up underneath the negative 2x. 1 times negative 7x squared would be a negative 7x to the second that I could line up under its like term. And then 1 times negative 9 is negative 9. And I could line that up under the 7. And then combine my like terms using my rules for positives and negatives. So 4 and negative 7 combine to give me negative 3. And then keep the x to the second. Negative 2x and positive 3x will combine to give me a positive 1x. And sometimes you'll see the 1 written, sometimes you will not. And then 7 and negative 9 will combine to give me negative 2. So that would be a correct answer. You might also see it written again without the 1 in front of the x. So either one of those answers would be correct. All right, so this will apply even when we're not using x's. So again, I could think of taking 1 and distributing it to each one of my terms, and I would have 2a minus 4b minus c, and then taking 1 and distributing it to my terms. I have negative 2a, negative b, and negative 4c. And so when I combine my like terms, 2a and negative 2a will cancel, and we don't write 0a, we just drop that term. Then I have negative 4b and negative 1. This is like a negative 1b. So that will combine to negative 5b. And then I have negative c and negative 4c. And again, this negative c would be like a negative 1. And so negative 5c. And those would be my like terms that I've combined. And then our last one, and I'll do it again by stacking them up just so you can see the difference. So removing the parentheses, 2x to the second plus 5xy plus 4y to the second. And then as I remove my parentheses for the next one, I could line up vertically the like terms. So the negative xy, that would be like a negative 1xy. The negative 6x to the second would line up under the 2x to the second, and the positive 2y squared would line up under the 4y squared. So we'll combine those like terms. 2 and negative 6 combine to negative 4. We'll have x to the second. Positive 5 and negative 1 also combine to positive 4. We'll keep the xy. And then the 4y to the second and the 2y to the second will combine to 6y to the second. And there you have the adding of like terms. If you'll turn your paper over, we will continue on with the subtraction part of your lesson. So we will continue on with subtraction. And the big difference with subtraction is that when you remove the parentheses, the second parentheses is going to be changed because now you're not just distributing a 1 to remove the parentheses, you're distributing a negative 1. So the first parentheses will be unaffected when you remove it, thinking again like you're distributing a 1. So you would have 6y to the second plus 8y to the fourth minus 5y. But on your second parentheses, you think of distributing a negative 1, and so now signs are going to change. So we'll have negative 9y to the fourth, and then negative 1 times negative 7y, we would have positive 7y, and negative 1 times 2y squared, we would have negative 2y to the second. So then you can combine your like terms. Now this one, the 8y to the fourth is not listed first, but it's the highest exponent, and so that's where I'm going to start. So 8y to the fourth combined with negative 9y to the fourth will give me negative 1y to the fourth. I do not have a y to the third in this problem, but I do have a y to the second. So 6y to the second combined with negative 2, y to the second will be positive 4, y to the second. And then finally, I have negative 5y and positive 7y, and those will combine to give me positive 2y. So you'll really be doing what we did on the front side with addition after you get the sign changed in that second parentheses. So we'll look at number 6, and I will do it by stacking up like terms. So our first terms, or our first parentheses, we have 6n to the second. Now it is positive. When I'm writing this, I'm going to put the 11 into the third in front because it has a higher exponent, and then plus 2n at the end. And then I'm distributing a negative 1. So negative 1 times 4n will make negative 4n. Negative 1 times negative 3. Now, that's a constant. I don't have a constant in that top row. So I'm going to put my constant, and it's positive. Negative times negative makes positive. I'll just put it out to the side. And then negative 1 times 5n to the second makes negative 5n to the second, which will line up under its like term. Then we'll combine. So just as we did with the other side, we'll have 11 n to the third. We have 6 and negative 5. That will add up to 1. You can put the 1 or not. It's maybe a little more simplified not to write it, but it is the same as putting 1 n squared or just n squared. Positive 2n and negative 4n would combine to negative 2n, and then the positive 3 would just be brought down into the answer. So there you have number 6 completed. And then finally, number 7. Now we have 3 parentheses. So notice that the sign in between each of them is subtraction. So our first parentheses, we will just take 1 times each one of those and make no changes. So 6f to the second minus 7f minus 3. And then we have our negative 1 distributed to 5f to the second. So that would be negative 5f to the second. We have negative 1 times negative 1. That's positive 1. We have negative 1 times 2f, and that would be negative 2f. And then likewise, we have a negative sign again. So we'll do negative 1 times 2f to the second. We'll have negative 1 times negative 3. That makes positive 3. And negative 1 times f, which makes negative f, or negative 1f. I'm just going to put negative f so you get used to seeing that. All right, so then we look for our like terms. So I want to look for everything that has an f to the second. And I'm going to combine 6 and negative 5, and that makes 1, and combine that with negative 2, and that makes negative 1 f to the second power. Then I'll move to f, so negative 7f. I have a negative 2f, and I have a negative 1f. So negative 7 and negative 2 make negative 9. Combining that with negative 1 makes negative 10f. And then finally, I have my constants. I have -3, I have 1, and I have +3. Now, one thing I could notice is the -3 and the +3 cancel or make 0, and then when I add 1, I get 1. Or I could go in order, -3 plus 1 is -2, and then when I add +3, I'll get 1. So -1f to the second minus 10f plus 1. So subtraction after removing the parentheses by changing signs works just like it did on addition. We have one last section where we're going to solve an equation. So I'll scroll down to problem number 8. It says the perimeter of the pentagon. Pentagon means that we have 5 sides. So pentagon will be a 5-sided figure. And the perimeter, so perimeter means that you would add all the sides. So the word perimeter would mean to add all the sides together. And so we're going to take all 5 sides and add them up. And then the word is means that we'll have an equal sign, and it will equal 62. So we'll take 5x plus 4. There's this side. So I'm going to mark that one that we have used it. We'll add to that 16. We will add to that 2x minus 3. We will add to that x plus 1. And we will add to that 3x. And it said the perimeter is equal to 62. So we'll combine our like terms. We have 5x. We have 2x. We have 1x. And we have 3x. So 5 plus 2 makes 7. Plus 1 for the 1x makes 8. Plus 3 makes 11. So 11x. And then we have our constants. So we have 4 and 16. That makes 20. Minus 3. That makes 17. Plus 1. That makes 18. So we have 11x plus 18 equals 62. Now we're going to do a little review of solving equations. You want to have the 11x be by itself on one side of the equal sign. So we'll do the opposite of adding 18, which would be to subtract 18 from both sides of the equal sign. So now you have an equal sign. So you have to think of that as staying balanced. So now we have 11x equals, and then 62 minus 18 would be 44. And then to solve that, we have 11 times x. So we'll need to divide both sides by 11. And that will give us x equals 4. Now we want to make sure that we answer the question that was asked and not just stop at what x equals. It did ask us to find the measure of each side, and it might be nice to put some letters on these sides so that we could refer to them that way. So I'm going to do that. This will be A, B, C. I'm putting them at the vertices, at the vertex point of each side of each angle. And so side A, B would equal 5 x, now our x turned out to be 4. I'm going to put a parentheses where that x will go in. And since our answer turned out to be x equals 4, we'll have 5 times 4 plus 4. Side AB is going to equal 20 plus 4, or 24. Then we'll do side BC. Side BC said it was 16, so there's no work to do there. That side was 16. Side DC, or CD, either one, let's go CD, is equal to 2x minus 3. So the x that we found was a 4. X was equal to 4. So 2 times 4 is 8, and 8 minus 3 is 5. Then we have side DE, and side DE was x plus 1. So our x and then plus 1. Our x turned out to be 4. So 4 plus 1, that side also is equal to 5. And then our last side, AE, and side AE said that it was 3x. So 3 times our value for x. Our x was a 4. And so 3 times 4, side AE, turns out to be 12. And if we add all those numbers together, we would get 62. So the perimeter of that pentagon would be 62. So these will be how your homework problems will work. Good luck, and be sure that when you have questions, you let your teacher know so that we can help you.